Welcome back to the deep dive. Today, we're strapping on our technical helmets, really. We're descending into the foundational architecture of, well, the modern private cloud, VMware Cloud Foundation, or VCF.
Yeah, VCF.
We've got a really highly focused stack of sources here drawn from, real-world operational scenarios. It gives us a perfect shortcut, I think, to VCF operational mastery.
These sources are great, actually. They really cut through the marketing fluff, don't they? They tell you exactly which specialized service is doing which critical job.
Exactly.
And look, we're not here just to memorize answers for some tests. We want to get at the foundational knowledge, the 10 sort of must-know components that really guarantee VCF stability, security, and performance.
That's absolutely the mission. We want you, the listener, to walk away understanding the structural why behind VCF's design choices.
Oh.
So let's unpack this. Let's start right at the beginning. Architecture and boundaries. If you look at VCF, it's a massive integrated system, right? But it has to be broken down into discrete, manageable chunks. So what is the core logical construct? The thing that defines the boundaries for resource and, maybe more critically, fault isolation.
Right. That defining boundary is the workload domain. You should think of it as like a virtual data center, built specifically to contain a set of resources for a specific purpose, maybe a dev environment or, a mission-critical LOB app.
Okay, workload domain. But why does this matter beyond just, neat organization? What's the practical impact of isolating resources this way?
Well, it's really an architectural trade-off, and it heavily prioritizes stability. The source confirms this. Each workload domain gets its own dedicated vCenter server and its own dedicated NSX instance.
Okay, so separate management for each.
Exactly. If you have 5 domains, you literally have 5 dedicated management sets. This physical separation of the management plane ensures that if a component fails in domain A, well, that fault is contained. It has a much lower chance of spilling over and messing with workloads or management bits in domain B. It gives you that guaranteed resource and fault isolation, which for large enterprises is just non-negotiable.
Got it. Containment established. Okay, now let's talk access, because these domains aren't much use if nobody can actually log in, right?
Yeah, that's right.
VCF relies heavily on external identity systems, things like Active Directory, obviously. So imagine a new user, they're authenticated via AD, they try to access a VCF service like, say, ARIA Automation, the management suite, and boom, access denied.
A failure.
Yep, I've seen that happen.
You might immediately think, oh, it's vCenter or maybe ARIA itself, but the sources point somewhere else first. Where is the first point of failure you should check for that external authentication attempt?
The first gatekeeper, the critical choke point there, is the identity broker.
The identity broker. So wait, you're saying before the user even talks to ARIA or vCenter, they have to go through this identity broker first. Why is that component so ruthlessly prioritized ahead of the services themselves? It really comes down to a design choice for centralized control. VCF is built on this idea of federation, establishing trust with an external system like AD.
Right, federation.
The identity broker is the single component that does that handshake. It validates the trust relationship with AD, and if that's successful, then it mints the authentication token.
The token.
That token is what the user then presents to vCenter or NSX Manager or ARIA. So if the identity broker fails to do that initial handshake, the user can't proceed, full stop. It's really the foundation of their whole centralized identity management approach.
Okay, that makes perfect sense.
Okay.
You got to establish the trust before you even think about granting access. All right, let's shift gears a bit. From identity to initialization thinking about the essential operations of setting up the physical architecture safely and correctly.
Yeah, and this is where, operations really trumps architecture sometimes. Seemingly minor details can absolutely ruin an entire setup attempt.
Oh, absolutely. It's always the simplest things that catch you, isn't it?
Always.
We've all spent hours debugging complex service accounts, maybe firewall rules, only to find the problem is layer 0 stuff, physical or basic config.
Exactly.
So take commissioning a new set of ESXi hosts and SDDC manager, that's the main orchestration engine for VCF. The process kicks off, but then fails during validation. What common, oft-overlooked prerequisites are consistently the most likely culprits there?
Well, you might initially check things like hardware compatibility, maybe licensing status, but the sources confirm this is usually almost always caused by foundational configuration issues.
Yeah.
Specifically, the hosts are not reachable via DNS or they don't have the correct NTP configuration.
DNS and NTP. So synchronized time and proper name resolution.
Yeah.
They trump pretty much everything else at that stage.
Pretty much, yeah.
Okay, here's where it gets really interesting for me. Why does SDDC Manager care so deeply about time and names? What's the underlying reason?
It really boils down to automation reliability. SDDC Manager is this complex orchestration system, right? Built on tons of API calls, automation routines.
Hmm.
If it calls a host name, maybe sxi-era1.corp.local, and DNS gives it an inconsistent IP address or no address, the whole setup sequence just breaks. It can't guarantee it's talking to the right server.
Okay, consistency.
And similarly, time synchronization via NTP is absolutely vital for security auditing, for ensuring all components, vCenter, NSX, SDDC Manager itself, agree precisely on when an action took place. If the timestamps are off by even a few seconds,
Yeah.
security mechanisms, logging systems, they might assume configuration drift or even a potential threat. And the validation routine just fails immediately. It's simply non-negotiable for the automation engine to proceed.
Wow. Lesson learned.
Oh,
Check your clock and your host name first, people.
okay. Now let's talk safety nets. We're running a major VCF upgrade using SDDC Manager. Big changes potentially. What is the absolute non-negotiable best practice to ensure you have a dependable rollback plan if, the automation goes sideways? Right? Things can go wrong. The critical best practice here is taking reliable backups or snapshots of the critical VCF management components. We're talking about the management plane, vCenter, SDDC Manager, the NSX managers, and so on.
Okay, back up the management plane. We hear backup all the time, obviously, but why is backing up this specific set of components prioritized over, say, protecting the actual tenant VMs that are running the business applications? Seems counterintuitive, maybe.
It does seem that way at first glance, but think about it. The management plane is essentially the brain of the entire VCF platform.
The brain.
It controls the networking, the storage, the automation, the orchestration, everything. If the upgrade corrupts that management plane, the entire environment is effectively frozen. You can't manage anything. Even if the workloads themselves are technically still running, you're blind and powerless.
Ah, okay. So you can't fix anything if the control system is broken.
Exactly. If the upgrade fails, recovering that management structure is the absolute first priority. Once the brain is back online, then you can focus on the body, the workloads.
That provides really critical context for prioritizing recovery efforts.
Makes sense. Let's shift gears again, maybe towards connectivity and resilience now, focusing on how VCF talks to the outside world and also how it moves things around internally.
Right, this is where we bridge that gap, between the virtual overlay network inside VCF and the physical world outside.
So when tenant workloads, the VMs running inside a workload domain, need to communicate with external networks, that classic north-south traffic flow, where's the critical exit ramp? What component acts as that translation layer between the internal virtual network, the NSX stuff, and the physical network?
The VCF support professional, or the architect, must ensure the NSX Tier 0 gateway is correctly linked up and configured with the physical external routers. That's the key component.
The Tier 0 gateway, that's the component doing the magical translation, right, between virtual and physical. Exactly. Inside the workload domain, all the traffic is zipping around on NSX overlay networks. Those are logically isolated. The Tier 0 gateway is the component that performs the actual routing function. It advertises the internal VCF networks to the physical router sitting outside the VCF environment.
So it's more than just a router.
Oh, yeah. It often acts as the firewall, potentially a load balancer, and the router all rolled into one virtual appliance. It provides that essential connection point for tenant traffic to reach the corporate network or, the public internet. Without a properly configured Tier 0, your workloads are basically marooned on a virtual island.
Marooned, I like that. Okay, moving on to migration then. Let's say you need to perform a really seamless move, maybe even a live vMotion of virtual machines between two different VCF data centers.
Sure.
Or maybe even stretch into a hybrid cloud environment. And the kicker is, you absolutely must maintain the original IP addresses of those VMs. What specialized tool is crucial for that specific task?
For that, you absolutely need the HCX manager. HCX stands for Hybrid Cloud Extension.
HCX. Okay.
Yeah.
It seems like HCX is specifically designed to solve one of the trickiest parts of migration, maintaining layer 2 network continuity, right?
Mm-hmm.
Why is that L2 extension piece so darn important in this scenario?
Oh, it's everything. It's the secret sauce. Normally, when you move a server, a VM, to a new physical location or data center, you almost always have to re-IP it to match the new subnet there.
Right, which means downtime, config changes.
Exactly. Downtime, application reconfiguration, potential headaches. HCX Manager is specifically designed to stretch the layer 2 network, the actual broadcast domain between the source and destination site.
And stretch the network itself.
Effectively, yes. It creates a secure tunnel. This means the VM, when it lands in the new data center, still thinks it's on its original network segment. It keeps its IP address, its MC address, everything. This allows for truly seamless, non-disruptive migrations, even live migrations in many cases.
That's pretty powerful stuff for mobility.
Yeah.
Okay, let's turn towards extreme resilience now. Thinking about vSAN stretch clusters. So we're stretching compute and storage across two physically separate availability zones, AZs. If the network link between those two primary AZs gets severed, what prevents that dreaded split brain scenario, where both sides think they are the primary and start accepting rights independently? Chaos.
Right. Split brain is bad news in storage. The arbiter, the tiebreaker in the situation is the witness host.
The witness host. Okay. It acts as this sort of non-participating referee, right? But what exactly does it store? And how does it actually prevent that conflict?
Yeah, referee is a good analogy, and that's the key distinction, what it doesn't store. Crucially, the witness host provides the tie-breaking vote needed for quorum detection. It ensures data integrity, but it stores only metadata and lightweight vote information.
No actual VM data.
No workload data whatsoever. Its sole purpose is conflict resolution. If AZ1 and AZ2 lose their connection to each other, they both try to check in with the witness host, which usually sits in a third independent location.
Okay.
The site that successfully maintains connectivity to the witness host is deemed the authoritative one and continues normal operation. The other site, the one that can't reach the witness, realizes it's isolated and typically shuts down write access to its copy of the vSAN data store. This prevents the split brain.
Very clever. A lightweight referee in a third location breaks the tie. Okay, that brings us neatly to our final section, the VCF Management Toolkit. Thinking about monitoring, security, diagnostics, the day-to-day stuff.
Yep, keeping the lights on and troubleshooting.
So in these large deployments, you've got multiple workload domains, right? Each potentially with its own vCenter, its own NSX manager. When an engineer needs that unified view access to performance metrics, centralized alerts, overall health reports for the entire VCF fleet, not just one domain,
Right.
what dashboard are they opening up? What tool provides that single pane of glass?
For that fleet-wide view, they're using the VMware Operations Console, which is part of the broader Area Operations suite. Used to be VLIS Operations or VROps.
Area operations, okay. Why can't they just use the vCenter server for that domain? What specific gap does the Operations Console Area Ops fill for the operator?
Well, as we established, VCF is inherently decentralized by design, mainly for isolation purposes, right?
Right, the workload domains.
So each domain has its own vCenter, and vCenter is fantastic for deep dives into cluster health, VM, performance within its domain, but it only sees its own little world. Area Operations solves the centralized visibility problem. It aggregates health data, capacity metrics, performance trends from across all workload domains, all the vCenters, all the NSX managers, even the SDDC manager itself, into one consolidated view.
The big picture.
Exactly. It provides that predictive analytics capability, the capacity planning view. That's just essential for managing a large, sprawling VCF fleet proactively rather than reactively.
Okay, makes sense for scale. Let's drill down now into troubleshooting a specific, maybe tricky security issue. Let's say we're diagnosing a packet drop. We suspect it's caused by a distributed firewall policy rule between two virtual machines on the same network segment. We need a surgical tool, something that shows us exactly where that packet died in the virtual stack, which NSX utility is necessary for tracing that path.
For that level of detail, you absolutely need the traceflow utility.
Traceflow. How does that actually work? How does it isolate a security policy failure versus, say, just a routing error somewhere in the virtual network?
So traceflow is cool because it doesn't just monitor existing traffic passively, it actively injects a synthetic packet and simulates its path from the source VM to the destination VM entirely within the NSX virtual network stack.
It simulates the journey.
Precisely. And as that simulated packet travels, the utility reports back exactly which component acted on it, which logical router it hit, which logical switch it traversed, and crucially for your question, which specific distributed firewall rule either allowed it to pass or, more importantly, dropped it.
Ah, so it names the culprit rule.
Yes. It turns that vague, hey, why can't VM A talk to VM B kind of problem into a very precise, okay, distributed firewall rule number 203 is blocking TCP port 443 between these two VMs diagnoses. It's incredibly powerful for pinpointing those policy issues.
That sounds like the ultimate surgical strike tool for NSX troubleshooting.
Fantastic.
Fantastic. Okay, finally, let's talk about security housekeeping. Certificates, they expire, they need renewal. When SDDV Manager handles an automated certificate renewal task, which group of components is actually targeted for this critical process? Is it just NSX, maybe just vCenter, or is it broader?
It's definitely broader. The automated process targets all core management components.
All of them, wow. Is that not overkill? I mean, why can't you just renew the certificate on, say, NSX Manager, which is often the most visible security component dealing with firewalls and stuff?
It might seem like overkill, but it's absolutely mandatory for maintaining trust within the management plane. VCF relies on incredibly complex, secure inter-service communication. For example, SDDC Manager needs to talk securely to vCenter, which needs to talk securely to NSX Manager, which might talk back to SDDC Manager.
It's all interconnected.
Highly interconnected. If you only renew the certificate on one piece, let's say just vCenter, but the others, like SDDC Manager or NSX, are still expecting to validate against the old, soon-to-expire certificate, well, the secure communication channels break down instantly. You get certificate mismatch errors everywhere.
And things stop working.
Things stop working, automation fails. To maintain operational stability and that chain of trust across the entire management plane, the renewal has to be comprehensive and essentially simultaneous across every core management component that relies on those certs. Well, thanks for diving deep with us today.
Yeah, this was fantastic. We'll catch you on the next deep dive.